Now all of you can give your attendance. I repeat, all of you can give your attendance in the chat box. I repeat, all of you can now give your attendance in the chat box. Those who have given earlier, please ignore. Again, you have to give your attendance. Can anyone tell whether my slides are visible or not?
Yes, sir.
Okay, so actually, this class was supposed to take by Kaustav sir from 9:30 a.m. to 11:20 a.m. but he's having some work, so he will not be able to take the class. He told me to take this class. So since in this class electrical people are not involved, so I cannot start the new topic. What I can do is that I can give you a brief introduction about the new topic. I will give you some that introduction, that is the last part of this module. So I will give you some introduction regarding what we will be doing in that part, and as well as we will be solving some little bit more complicated problems in today's class. Okay? Hello.
Yes, sir.
Fine. Okay. So let us solve the first problems. Today we will solve two little bit complicated problems, and after that in the next lecture I will give you some basic concepts about the last topic of this module which we will be going to cover, and the detailed portion we will cover in the class of Wednesday, because in that Wednesday class electrical people will also be there. Okay. So let let us read the problem. What the problem tells you. The problem is two cylinders having weight WA equal to 2000 Newton and WB equal to 1000 Newton are resting on smooth inclined planes having inclination 60 degree and 45 degree with the horizontal respectively as shown in the figure. They are connected by a weightless bar AB with hinge connections. The bar AB makes 15-degree angle with the horizontal. The bar AB makes 15-degree angle with the horizontal. Okay, people are joining. Wait a little bit. The bar AB makes 15-degree angle with the horizontal. Find the magnitude of the force P required to hold the system in equilibrium. That means what is given to you in the problem? In the problem, there are two cylinders A and B. Weight of cylinder A is 2000 Newton, acting vertically downward from its center of gravity, and the weight of cylinder B is 1000 Newton, acting vertically downward from its center of gravity. Cylinder A is placed on an inclined plane, making an angle 60 degree with the horizontal, whereas the cylinder B is placed on an inclined plane, making an angle 45 degree with respect to horizontal. Both the cylinders are tied together by a common string AB, and that string or that bar is making an angle 15 degree with respect to the horizontal axis, that is making from the point B. And on this cylinder B, a force or a load P is applied at an angle of 60 degree with respect to the vertical. You need to find out what will be the value of force P, how much force P you will apply at cylinder B so as to keep the entire system in equilibrium condition. Is the statement of the question clear? Any doubt in understanding the question?
No, sir.
Okay. Other people, please respond. I got answer from one person. If some more people can respond, whether the statement
Yes, sir.
question is
Yes,
clear
sir.
or not. Hello. I'm waiting for
Sir, no
your.
problem.
Is it clear, right? Okay.
Yes, sir.
Okay, fine. So now tell me how we will proceed. What is the first step? What we will do?
Sir, free body diagram.
First step is we have to draw the free body diagram of this problem. So in order to draw the free body diagram, first of all you have to identify the object of the problem, because on a particular object you draw a free body diagram. So can you identify the object of the problem? That means on which object I will be drawing the free body diagram.
Here on A and on B.
What is A? What is B? A and B can be anything.
Say A
I want the name
the
of the object.
cylinder A and cylinder B.
Yes, yes. I from the diagram which is given in the question, it is very much clear that A and B are the two cylinders, and we will consider or we will be drawing the free body diagram of both the cylinders separately, and then we will try to see which equation is easy to get the unknown values or unknown parts of the problem. We can get it through Lamy's theorem, we can get it through equilibrium equations. For that we have to first draw the free body diagram of cylinder A and B separately. Then by looking to the free body diagram, then we have to decide that which equation is suitable to get the unknown values. Is it clear? Any doubt so far?
No, sir.
Okay, fine. So let us draw the free body diagram of cylinder A first. Can you tell me in cylinder A how many forces will act? Total number of force? By looking at the diagram of the problem, can you tell me that on cylinder A how many forces will act?
So three.
Three forces, one, two, three, correct? There will be in altogether three forces. Now, can you tell me what are those three forces and how they will act on cylinder A?
Sir,
So one.
one is the weight and
एक एक करके
second is
एक आदमी बोलेगा पहला फोर्स, दूसरा आदमी बोलेगा दूसरा फोर्स, तीसरा आदमी बोलेगा तीसरे फोर्स के बारे में। बोलो फर्स्ट फोर्स।
one is the weight.
One is the weight of the cylinder, which is acting vertically downward from the center of gravity of the cylinder. And from the diagram, it is very much clear that the center of gravity is nothing but the center point A. So from point A, in vertical downward direction, weight of the cylinder is acting. That is 2000 Newton, which is clear from the diagram of FBD. Okay. Next force.
So another reaction force will act on the cylinder A by the 60-degree wall.
Yes, that means the second force which will be exerted or which will act on this cylinder A is a reaction force, and that reaction force will be given by this 60-degree inclined plane. Yes or no? Hello.
Yes, sir.
Yes, sir.
Fine. Okay. So let us draw that reaction force which the inclined plane will give to the cylinder A. So that means that means this inclined plane will give a reaction force RA in this direction. Is it clear? And I have to extend this outward a little bit like this. That means this is the direction of reaction RA. Any doubt? Hello.
No, sir.
No, sir.
Okay. But now you have to decide that how much is the reaction force RA is making an angle at point A. For that, can you tell me how much is this angle, that reaction force which is
So
making
90
with this
degree.
inclined plane? This is
90 degree.
90 degree.
90-degree. I know that reaction force always makes an angle of 90-degree with the object, that is Newton's third law of motion. We have already studied. This angle is 90-degree. If this is 90-degree, if and this angle is 60-degree, and we consider this particular triangle, we can easily find out this angle. Can you tell me how much is this angle?
So 30 degree.
This angle will be 180 minus 60 plus 90, minus 60 plus 90, that is 30-degree. So this angle is 30-degree. If this angle is 30-degree and point A is the equilibrium point for cylinder A, then from point A I can draw this axis. This is nothing but my x-axis, and this is nothing but my y-axis. If this angle is 30-degree, definitely by geometry this angle is also 30-degree. And if this angle is 30-degree, then this particular angle, that is vertically opposite angle, this angle is also 30-degree. So you got this particular angle as 30-degree. Is it clear? Any doubts so far?
No, sir.
Okay. So we are done with 2000 Newton force. We are done with RA force. One more force is acting on this cylinder A. Can you identify that force?
Yes, sir, along BA. Of course.
That means the bar. Since cylinder A and cylinder B is connected with a common bar AB, that means the bar AB, or I would say BA, because if I consider cylinder A, the bar will be B2A, because B is, that means the cylinder B is giving some reaction to bar BA, and that bar BA is giving that same reaction to the equilibrium point A. So I should write it as force FBA. Is it clear? FBA. And when we will consider cylinder B, in that case the bar AB is connected from A to B, then cylinder A will give a force or a reaction force on bar AB, and then bar AB will give the same reaction force to the equilibrium point B of the cylinder. So when we will consider the free body diagram of cylinder B, I will write that force by FAB, and when I am considering the free body diagram for cylinder A, I will write that force by FBA, and FBA is equal to FAB. Is it clear? So that's why this value will be FBA. Is it clear?
Yes,
Any
sir.
doubt? Here you can make one mistake. What mistake you can make? You can write F of AB, but that is physically not correct. Mathematically it is correct. If you, in place of FBA, if you write FAB, mathematically it is correct, but physically it is not correct, because when you are considering the FBD of cylinder A, it is very much clear from the diagram that cylinder B is exerting a force on bar BA, and then bar BA is exerting the same force on the equilibrium point A. So that's why I have written FBA. I haven't written FAB. Fine. Okay. Now let us see how much angle this force FBA is making at the equilibrium point A. If you see, this particular angle is how much? This particular angle is 15 degree. If this is 15 degree, definitely this angle is also 15 degree by geometry, and the direction of FBA will be in this direction. This is the direction of the force FBA, that is FBA. Clear? That means this angle 15 degree is nothing but this angle 15 degree. So if I extend this force line along this end, this will be my FBA, and if this angle is 15 degree, definitely this angle will also be equal to 15 degree. That means this particular angle is also 15 degree. So in this my FBD of cylinder A, I can extend this RA line. This will be the direction of RA. If this is 30, this angle is also 30, and I can extend this FBA line in this direction. This is my FBA. If this angle is 30, then definitely this angle is also 15. Sorry, if that angle, this angle is 15, then this angle is also 15 degree. Is it clear? Now my FBD of cylinder A is complete. Do you have any kind of doubt?
No, sir.
No, sir.
Okay, so let us draw this FBD separately. Say this is my point A. From point A, weight is acting vertically downward, which is 2000 Newton. From this point A, the reaction force RA is acting in this direction, and it is making an angle of 30 degree with positive x-axis. This is x. This is x-axis. This is x-axis. This is y, and this is y. So this particular angle is 30. Then this is your FBA. This is the direction of FBA. FBA, and Since this angle is 15 degrees, so this angle is also 15 degree. That means this angle is 15 degree. Okay. No, now in order to keep the system in equilibrium, or in order or if you consider the cylinder A to be in equilibrium, then at point A you have to use some equations to get the value of FBA and RA. So which equation will you use? Will you use Lamy's theorem, or you will use equations of equilibrium or something else? Which equation you will use now to get the values of unknown FBA and RA?
So we will use normal equilibrium equations. Then we will get two equations, and by solving them, we will get the values.
Yes, that also you can use, and Lamy's theorem also you can use, because what Lamy's theorem says that if three forces are passing through a common point when the body is in equilibrium and those three forces are concurrent in nature, then according to Lamy's theorem, force divided by sine of angle between the opposite forces, that will be equal to each other. So let us use Lamy's theorem. Our process will be more simpler, it will take less time, it will take less space. So let us use Lamy's theorem. What is Lamy's theorem? Force 2000, that is 2000 divided by sine of angle between the opposite two force, that means this angle. Can you tell me how much is this angle?
135.
135. How it is 135? That is 180 degree. This entire is 180 degree minus 30 minus 15. So this angle is 135. So 200 by sine 135, which is equal to FBA. That is FBA by sine of angle between RA and 2000. That means this angle. Can you tell me how much is this angle?
So
How
120.
much is the angle between RA and 2000? How much will be this angle? Angle between force RA and 2000?
30 plus
So
90.
120.
90 plus 30, that is 120. FBA by sine 120, which is equal to RA by RA, that is this is my RA divided by sine of angle between FBA and 2000 Newton. That means this much angle. Can you tell me how much is this much angle?
105.
90 plus 15, that is 105 degree. Fine. So if we take the first and the second as a combination, so I can write 2000 divided by sine 135 is equal to FBA by sine 120. Then FBA becomes 2000 into sine 120 divided by sine 135. If you solve this expression, you will get the value of FBA to be 2449.48 Newton. If in the question it has been told to you that also find the value of force which is exerted by the bar, then this is your answer. And if in the question it has been told to you that also find the reaction which the inclined plane is exerting on this cylinder A, then your answer will be this RA. Then you take the first and the third combination, or the second and the third combination, solve it, you will get the value of RA. Is it clear so far? Any doubt? Any doubt so far?
No, sir.
Okay, so next, since in the question we have to find the value of P, this force P, fine. So from FBD of cylinder A, I got the value of FBA. Now I will be using this value of FBA in free body diagram of cylinder B. Then in that case only One force is unknown, that is force P, and easily we can find out that force P. So before that, what we will do now, individually, now we will draw the free body diagram of cylinder B by considering point B to be the equilibrium point. So let us draw the free body diagram of cylinder B. Just a minute, let me erase all these things. Okay. So for cylinder B, I have to draw the FBD. So first of all, tell me how many forces are acting at cylinder B. Tell me how many forces are acting at cylinder B.
Sir, I think it's 4.
There are four forces. Okay. Anybody else? Anybody else? If you can say, one person has told
Sir,
there will
4.
be four forces. फोर. ओके. और किसी का कोई कुछ दूसरा आंसर है फोर के अलावा? Okay. So there will be total four forces that will act at the center point of cylinder B. Now, can you name those four forces one by one?
Sir, if AB, then the reaction force to
Uh,
the
FAB, that will be given by the bar AB towards point B. Okay, fine. Next.
sir, then the reaction force given to the cylinder B.
Reaction force given to the cylinder B. Which reaction force? Which
So from the
reaction?
inclined plane,
45 degree
45 degree.
angle.
From the inclined plane. That means
Inclined plane.
inclined plane will give one reaction force to cylinder B. Okay. Two forces, remaining two.
So P and the mass acting vertically downwards. From
Force P, which is acting at an angle of 60 degree. Already it is given in the problem. And the last force is the weight of the cylinder acting vertically downward from its center of gravity. These are the four forces acting on this cylinder B if we draw the free body diagram. So now let us draw the free body diagram of cylinder B. Let us draw. So from B, one force acting is your weight of the cylinder B, and that is nothing but 1000 Newton acting vertically downward. Second force is the force exerted by this bar AB, but this time the force will be exerted from cylinder A to the bar AB at point B. So the direction will be, this is the direction, and I will write FAB. And there is force P already acting at an angle of 60 degree, and the last reaction force is the force that is exerted by this inclined plane on this cylinder B, that means in this direction. So this is your RB, and say this is your x-axis, that means this is x, and this is y, this is y. Okay, so first of all, we have to find out the included angles present, if any, then only we will be able to solve the problem. So let us find out the included angles. this, if I consider this particular triangle, this is 45, this angle will be 90. How much will be this angle? This
45.
angle is 45, this angle is 90. How much will be this angle?
45.
It will be 45. That is 180 minus 45 plus 90. That means this angle is 45 degree. Okay. Next is, that means if this angle is 45 degree, then this angle is also 45 by geometry. Yes or no? Hello.
Yes, sir.
This angle is also 45 by geometry. So see, RB. So if this is 45, this angle is 45. That means pointer. Wait. Okay, I can extend this, well, RB like this. This is RB point. If this is 45, then this angle is also 45. If this is 45, this is also 45. Then the overall will be 90 degree. Okay, done. Next. Next is this FBA. If you see this FBA, it is making an angle 15 degree. So I can extend like this. This is your FBA. If this angle is 15 degree, definitely this angle is also 15 degree by geometry. Yes or no? Yes or no? Hello.
Yes, sir. Yes, sir.
This angle is also 15 degrees. So if we see the diagram, see this angle is 15 degree acting at this point. So what I can do, I can just extend it. So if you can extend it, this is your FAB. This is 15, then this is also 15. Fine. And the last one is this force P, which is making an angle 60 degree with respect to the vertical. So these are the four forces which are acting if we draw the free body diagram of cylinder B. Fine. Okay. So first let me erase. Okay. So by looking at this FBD, can you tell me that whether we can use Lamy's theorem to solve the problem or not, to get the values of unknown P and RB?
No, sir.
I cannot. Why I cannot? Because if you see at point B, four forces are acting, and Lamy's theorem is applicable for a three-force system. It is not applicable for more than three-force system. Here the system comprises of more than three forces. So I have to use only one equation, that is the equations of equilibrium. Since it is a two-dimensional body, so I will use the equilibrium equations as summation fx equal to 0. That means all the forces along x-axis is equal to 0 at point B, and all the forces along y-axis is equal to 0 at point B. So let us write down this expression, that is summation fx equal to 0 at point B. So at point B, force FB is acting. This is FAB. This is FAB. Fine. And this angle is given 15 degree. So I have told you how to resolve. See, that means this is the tail end of the vector and this is the head end of the vector. I have to go always towards the head end. How I will go? From here, if I go from tail end, if I go downward, and then from this end, if I go in horizontal direction, I will reach to this head point, and this angle is given to me, that is 15 degree. If this is the case, can you tell me what is the value of this horizontal component of FAB? Horizontal component of FAB is
FAB cos 50.
FAB cos 15. So this will be FAB cos 15, and this vertical component, that means this component will be FAB sin 15. Similarly, for force P, let us resolve it. Now, the direction of force P is like this. So, this will be the tail end and this will be the head end. How I will resolve? I will go from tail end in horizontal direction, and then from this end I will go vertical downward. Then I will reach to the head end, and this particular angle is 60 degree. So can you tell me what is the value of this vertical component? This is P. This is your P. Can you tell me what is the
P
value
sin
of the
60.
vertical component?
P sin 60.
P sin 60. Wrong.
Sorry, sir. P cos 60.
It will be cos 60. Why? Because angle is over here. If the angle is over here, this is hypotenuse, this is base, this is perpendicular. Then this vertical component will be P cos 60. And this horizontal component will be P sin 60. And the last force is RB, and this RB is acting in this direction. This is RB. Then if I want to resolve this RB, this end is the tail end and this end is the head end. I have to go from tail to head. How I will go? From tail end, if I drop a perpendicular vertically upward. Then from this point, if I draw a horizontal line towards negative x-axis, then I will reach to RB, and this angle is how much? This angle is 45 degree. If this is 45 degree, can you tell me what is the value of this horizontal component? What is the value of this
RB
horizontal
cos 45.
component? RB cos 45. So this is my RB cos 45, and my vertical component will be RB sin 45. So if I am writing fx equal to 0, what I can write? I can write plus FAB cos 45 because it is in positive x direction. Then minus P sin 60, it is in negative x direction. And minus RB cos 45 equal to 0. Is this equation clear? This particular equation? Any doubt in this equation?
No, sir.
Okay. So FAB already I have found out, that is equal to FBA 2449.48 into cos 15 minus P sin 60 minus you keep the value of RB towards right hand side, it will be equal to RB cos 45. If you solve further, this entire value becomes 2366.01 minus sine 60 is 0.866 times of p equal to cos 45 is 0.707 times of RB, or what you do is divide 0.707 throughout, then it will be RB is equal to 3346.54 minus 122 times of 4 into P, or you can write RB, this minus becomes plus if it goes to left hand side, 1.224 times of P equal to 3346.54, which is equation number 1. Any doubt in equation number 1?
No, sir.
Okay. Similarly, I can write summation fy also equal to 0. In that case, it will be plus RB. It will be plus RB sine 45 because direction is towards positive direction, minus FAB sine 15 negative direction, minus P cos 60 negative direction, minus this W, that is 1000 Newton. This will be the expression for F summation of Fy equal to 0. See, RB cos 45 minus P cos 60 minus FAB sin 15 minus 1000 equal to 0. Again, RB cos 45 is 0.707, cos 60 is 0.5, FAB already we have calculated, that is 2449.48 into sin 15 minus 1000. If you solve this equation, you will get equation number 2, that is RB minus 0.7072 times of P equal to 2311.13, equation 2. Now, in order to find out the value of P, you are having two equations, equation 1 and equation 2, as well as two unknowns. If you solve these two equations, you will get the value of RB, which is 2690.29 Newton, and the value of force P, which has been asked in the problem, that is 536.14 Newton. Is it clear? Any doubt?
No, sir.
Fine. Okay. Okay. So do one thing, then take a 5-minute break, and again I will be back with the same link. You have to join with the same link after say 10 minutes. Take a 10 minutes break and then again come back. Okay. Because since it is a 2-hour class, so that's why I'm giving you 10-minute break. Then at now the time is I think 10, 18, 19. We will start the class again by 10:30. Fine.
Okay, sir.
Okay, then take a 10 minutes break. We will be back by 10:30 with the same link. Okay.